So we have done a lot of work with lines, we've done some work with triangles, we've introduced you to proportions. So what we're going to talk about in this video is similar figures, and I'm going to start with using slope triangles in that discussion of similar figures. So I have this line that goes through points A, C, and L. And these green triangles represent two different slope triangles that I could use to find the slope of this line. So triangle ABC has a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a rise of 9 and a run of 1, 2, 3. For triangle CKL, we have a rise of 1, 2, 3, 4, 5, 6, and a run of 2. So I can say that the length of this side is 9, and the length of this side is 3, and the length of this side is 6, side KC, and the length of side KL is 2. Now, if we're looking at the slopes, the slope of the line using triangle ABC is 9 over 3. The slope from C to L is 6 over 2. And in each of these, I can simplify down to 3 over 1, or just 3. So I have the same slope. And also looking at these triangles, I have some corresponding pieces to them. Because my triangles are facing the same direction, where I have the horizontal pieces on the top and the vertical pieces on the right, and I have the slanted side that has the slope of the line on the right side, I have some corresponding pieces. I'm going to focus on the angles. Because these triangles are along the same line, the angles in these triangles are also going to be what we say are congruent. Congruent means that they have the same measure. Now, because we've been using right triangles, both of these triangles have right angles inside of them. So angle K and angle B, or angle LKC and angle CBA, are right angles, but also angle BAC is going to have the same measure as angle KCL. And angle BCA is going to have the same measure as angle KLC. Now I want you to notice that I used the same markings inside of the angles. So BAC has the same angle in it as KCL, or has the same marking inside the angle. And angle BCA, I put 2 arcs inside of it, has the same marking as angle KLC, 2 markings. That's because those angles are congruent. They have this exact same measure. So in these two triangles, we can say that angle B is congruent to angle K. We can say that angle BCA is congruent to angle KLC, and we can say that angle BAC is congruent to angle KCL. Because these angles are congruent, and these sides give me the same ratio, I can say these triangles are similar. They have the same shape and they have the same angles, making them similar triangles. And when we write that triangles are similar, we would write a statement that looks like this. Triangle BAC write that a little clearer. That A is not showing up so clear. BAC is similar, this notation is similar to triangle. So I need to write it in the same corresponding order. So I said BAC, that's going to be similar to KCL. KCL. Now for scale factor, we want to compare a measure from one triangle to another. So scale factor is not going to be the slope. Scale factor is the ratio of one side of one triangle to the corresponding side of another. And when we find a scale factor, we're going to take a side from the second shape mentioned and compare it to its corresponding side in the first shape mentioned. So I can take this horizontal 2 and I can compare it with the horizontal 3, and that is my scale factor. Now that one is already simplified, so I don't need to simplify it further, but I could also compare the vertical sides. 6 corresponds to the 9, so I could compare 6 to 9, which does simplify to 2/3. When we talk about scale factor, we look at the simplified form of the ratio. So while we could compare 6 to 9, they are the vertical sides of these triangles, we would want to use the simplified version of this of 2/3 to describe the scale factor of the two triangles. Another thing we could look at, I marked points along the line. And you'll notice that this part of the triangle along the line has 3 sections, whereas the smaller triangle, triangle KCL, has 2 sections along the line. So we've got 2 sections compared to 3 sections. So again, we have a ratio of 2 to 3. So every single set of corresponding sides, pair of corresponding sides, is in the same ratio. And you want to have that same ratio, that scale factor, for all of the corresponding sides. Now, similar figures doesn't just have to be for triangles. So I started with triangles just because we've been working with lines, we've been talking about slope, we've been using triangles with our slope. But it can be excuse me, trapezoids, it can be rectangles, it can be pentagons, it can be these arrows, it can be these quadrilaterals, it can be these dogs. It doesn't matter, they can be any shape as long as corresponding angles are going to be equal. And you'll notice that corresponding angles have the same marking inside of the angle. And then the sides have to have the same ratio when simplified. So corresponding sides will be in the same ratio. So let's take a look at this set of quadrilaterals. We've got BCDA and FGHE. So I know they have all of these corresponding angles are congruent. So we're going to practice writing some corresponding angles. Corresponding angles. And I'm going to write all of these angles with 3 points, because it takes 2 sides and a vertex to form an angle. And the vertex is always that middle letter. So let's start with the right angles. We have angle BCD is going to be similar, is going to be congruent. Congruent is an equal sign with that little wave. It's called a tilde above. This is the symbol for congruent. So angle BCD is congruent to angle FGH. Angle CDA has 3 arcs in it. CDA, it will be congruent to angle GHE because it also has 3 arcs in it. Angle DAB has 1 arc in it, will be congruent to HEF because it has the same marking. And then the 4th pair of angles, we have angle ABC is congruent to angle EFG. If I look at the ratios of all of my sides, so if I'm going from ABCD to EFGH, I want to take the lengths from EFGH and compare them to ABCD. So because I'm saying I'm going from ABCD to EFGH, I'm going to take the corresponding sides of my smaller quadrilateral and compare them to their corresponding sides on the larger quadrilateral. So 4 corresponds to 6. 6 corresponds to 9. 8 corresponds to 12. And 10 corresponds to 15. If I look at each of these ratios and I simplify them, 2 is a factor of both 4 and 6, so I can simplify 4 over 6 down to 2/3. 3 is a factor of 6 and 9. I can simplify that also to 2/3. 4 is a factor of 8 and 12. So 8/12 will also simplify to 2/3, and 5 is a factor of 10 and 15, causing that to also reduce to 2/3. That means we have a scale factor of 2 to 3. So because we have all of these corresponding angles congruent, and because the ratios of all of our sides are the same, we can definitely say that shape A, B, C, D is similar to E, F, G, H. And this statement, we call this a similarity statement, is always written in a corresponding order. So A corresponds to E, B corresponds to F, C corresponds to G, and D corresponds to H. So they're written in corresponding order. So let's determine if these shapes are similar or not. You want to make sure that you're comparing all of the possible ratios that you could have. So if I look at these 2 rectangles, all of the angles are right angles, so I know I meet the requirement of corresponding angles are congruent. I need to compare my ratios. So my smaller side length would correspond to my smaller side length. So I'm going to compare 8 over 18 with the ratio of the longer side length to the longer side length, which is 16 over 24. Let's simplify each of those ratios. The largest factor of 8 and 18 is 2, so this reduces to 4 over 9. And the largest factor of 16 and 24 is 8, so this reduces to 2/3. Because these two ratios are not the same, they're not equal, this is not similar. These two rectangles are not similar. If we look at the trapezoids, we have 3 different ratios we actually need to compare. We need to compare 5.4 with 2.7. We need to compare 12 with 6. And we need to compare 16 with 8. So when I simplify each of these, 5.4 divided by 2.7 is actually 2. 12 divided by 6 is also 2. 16 divided by 8 is also 2. Because these are all the same, that means these trapezoids are similar. If I look at the next set of rectangles, again, compare the smaller side with the smaller side. So if I compare 20 to 15, and I compare the longer side with the longer side, 24 with 18, and I simplify my ratios. 5 is the greatest factor of 20 and 15, so this reduces to 4/3. 6 is the greatest factor of 24 and 18. 6 goes into 24 4 times, into 18 3 times. Again, these ratios are the same, so that means we have similar rectangles here. And if we look at the last one, again, if we look at this, I have 3 sides of this trapezoid that are the same length. If I look at the trapezoid above, do I have 3 sides that are the same length? I don't. So because I don't have 3 sides that are the same length, I can pretty much say that these are not similar without even using any ratios. Because I don't have that same relationship with 3 of the sides on the trapezoid on top as I do with the trapezoid on bottom. If they were going to be similar, I'd have to have that same relationship. Also, 742 over 7 is going to, or I should say 7 over 42, staying with the same way that I've been writing my ratios for the other 3, 7 over 42 is going to reduce to 1 over 6. If I compare 4 with 22, 4 over 22, the greatest factor of 4 and 22 is 2. So that's going to reduce to 2 over 11. Those are not the same. Because they are not the same, that also tells me it's not similar without even having to check all of the corresponding sides. So you want to make sure that the ratio of all of the corresponding sides is going to be the same. Don't just necessarily check a couple of them, but like in this case, I was able to check just a couple of pairs of corresponding sides. I did see a difference. Therefore, I was able to say not similar. So let's find the scale factor of these triangles. So it says find the scale factor from triangle RST to triangle XYZ. Because I'm told in this statement that these triangles are similar, I can take any corresponding sides and find my scale factor. I just want to make sure that I take a side length from triangle XYZ in my numerator. So I'm going to just take the smallest one, which is 12, and its corresponding side is going to be, if I go with XY, XY is the first two, it'll correspond with RS, which is 20. Also, because 12 is the smallest side of this triangle, 12 should correspond with the smallest side of triangle RST, which is 20. The greatest common factor of 12 and 20 is 4. 4 goes into 12 3 times. 4 goes into 20 5 times. So our scale factor is 3/5. Listing all pairs of congruent angles. So I'm going to have angle RTS is congruent to angle XZY. So I went RTS, XZY. Angle TSR is congruent to angle, so TSR is going to be congruent to ZYX. And then finally, we have angle SRT is congruent to angle YXZ. We can also list corresponding sides. So RT, and this particular notation actually means the length of RT, is going to correspond to XZ. Those are the sides that have the middle length on each triangle. TS is going to correspond to ZY. Those are the sides that have the longest side of each triangle. And RS is going to correspond to XY because those are the sides with the shortest length on each triangle. And let's just practice this with some quadrilaterals. So let's start by listing pairs of congruent angles. We don't have any measurements on this particular one, so we may need to use our similarity statement to help us here. So D corresponds with H. So because D and H were listed first, those angles correspond. E corresponds with J. So notice how I'm marking those angles the same. F corresponds with K. Again, I'm marking these angles the same. And G corresponds with L. So I've marked them in the corresponding order they were listed. So now I can list all my pairs of congruent angles. So we have angle GDE is congruent to angle LHJ. The markings inside those angles are the same. Angle DEF is congruent to angle HJK. Because they have the same markings. Angle EFG is congruent to angle, so we want the angle with 3 markings, JKL. And angle FGD is congruent to angle KLH, because they also have the same markings. For corresponding sides, you might want to look at what are the angle markings on each end of the sides to help you. So if I use side DE, I can either use the angle markings. I need to have 1 and 2 markings on each end, so that would be HJ, or I can look at the similarity statement. DE are the first 2 letters, HJ are the first 2 letters. So DE corresponds to HJ, EF, so the angles with 2 and 3 markings, the angles with 2 and 3 markings would be JK, but EF are the 2 letters in the middle. JK are also the 2 letters in the middle. We have side FG. FG has the 3 marks and the 4 marks on each end. So does KL, or FG are the last 2 letters, as are KL. And then finally, the last sides, we've done DE, EF, FG, we've got GD, GD, so the last letter and the first letter, so last letter and first letter should be LH. And if I look, that was 4 and 1. 4 and 1 would be LH as well. Again, this notation actually stands for the length of HJ or the length of FG. So that's what that notation means when I write it like that. So this is using similar figures to find corresponding pieces, and we can find scale factor knowing the lengths of corresponding sides of similar figures.